Okay. Yeah. I'm sorry. Yeah. 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 I was asking ChatGPT. Sorry, I don't know what to do. I'm a bit lost. No, I'm just kidding. I actually know what I'm doing. So let's talk about Aztec. So, namely, how can you do things to state in some contract or just make the chain say that something happened? I'm José Pedro. I'm a DevRel engineer at Aztec Labs. I'm very glad to be here. This is a big deal to me. So it seems like my clicker is not still thing. Okay. Oh, yeah, I need to turn it on. So yeah, there's this person. I guess someone that likes Ethereum. I was like thinking whether Ethereum is actually real life or not. And I met someone else that was also the same, I would say, conference, and they were thinking if it's actually just fantasy. And there was also like someone that says, "Oh, mama!" Oh, I'm kidding. Okay, this is too much. Yeah, I just came out of bed anyway. But what I want to do is just that you actually can't represent the real life in a global ledger because the causality in real life is private. But let's start from the beginning. This is too much. Let's start. How can you represent the real life if you're using the world's most expensive clock, which is Ethereum? So let's start with some agenda. Yeah, I even have an agenda. It's really cool. So let's talk about the secret to success. This is something I know. I'm going to give it to you. Then I'm going to tell you who you are, and then finally, tell about the world's most expensive timestamp machine, which again is Ethereum. And then I'm going to explain to you how can you keep your secrets when you shout them out loud. There's going to be a demo at the end. Most of the time it's going to be a live demo for you to also try in your own machines. So, the secret to success and happiness. I know what is the secret to success and happiness. And I'm going to give it to you for free because I like you. And there's only two simple steps. Right? First one is you have to Trojan yourself. Okay? You're going to take all the real life assets, you're going to put them in a global, immutable, public ledger. Okay? If it seems like something you've seen before, that's just a coincidence. Nobody's doing this, right? Publicly, nobody's doing this, right? And then you just became a dictator. I mean, it's perfect. Like, you just can be happy, be successful, you can do whatever you want. It's amazing, right? But if you're not a dictator, I'm not, and if you want to be a dictator, then who do you want to be? Who are you? You need something, right? So I asked some world-class scientists about this, except not, but anyway, for example, I talked with some physicists. They said, yeah, definitely I can represent people as having a deterministic position, velocity. I actually have some code here. You can write a struct that has a position and velocity, but actually, do you need that? Do I need that to see that you are here? You do have a position and velocity, but it's private. I don't actually need to know that. As long as we agree what time is it, and that there's a common time, I don't need to know that. I can actually see the consequence of a cause without knowing the cause. The same for biology. You can have some blood pressure, you can have, whatever, glucose levels. Again, as long as we agree on a common sense of time, I know that you are here and you are alive. So, again, this struct is completely private. Can be private. Psychologists say the same thing. You have some memories. Memories are important because they rule the way that you engage with the world, and still I can see that you are engaging with the world. So you are a social being. So this is also something that affects the real life. And now you're like, why? What does this has to do with Aztec, right? You're just talking about random stuff. I said no, because actually, so far, all blockchains imply full knowledge of all the public inputs. Everyone needs to agree on everything, and everyone needs to know everything. And that's what Aztec decouples. So actually, the world is actually not random. It's just like you just see a ton of private execution that happens in our brains and even in nature, and we just don't know about it, and it still affects our environment. So privacy is quite a big deal, isn't it? It's kind of also a human right, and this is, I mean, this is just little book that says that privacy is actually a human right. I mean, it's just a universal declaration of the human rights, right? So it's kind of a big deal. You can't just ignore it. You also cannot just ignore it. You cannot ask someone to keep privacy, to say, oh, I'm picky promise you that I'll keep your data. There's even laws like GDPR that says that. There are people saying, oh, yeah, I trust your password will be safe with me. Please, yeah, you can trust me, etc., etc., etc. But actually, if you go and think about the blockchain without privacy is a willing nightmare. So there's a problem here that we need to figure out, right? Here's a tweet about privacy on Guard that I really like. It's like everyone is, oh, there's this new thing, blockchain, we're going to rule the world, it's going to crack down on financials, it's going to be a big deal, but then let's just put everything publicly on a public ledger. What? Right? Are we mad? Like, this is just wrong, right? So, in short, we are encoded with our secrets in real life. This is an example. I hate broccoli. So that's something I can add to my representation. And actually, I don't have to tell you that. If we're going to go to a restaurant or something, I'm going to choose a plate that has no broccoli because I know that I don't like broccoli. And I can even influence you to choose another plate that it's not broccoli because, I don't know, you just found that whatever I chose is best, and you would choose broccoli if I wasn't there. So I just kind of shouted that I hate broccoli without revealing anything. I'm not leaking any information about me. You just see the consequence of an action without knowing the causality. And with blockchains, everyone is leaking. Everyone is leaking your data. And this is something that your data just can't leave your machine. If it leaves your machine, it's not private anymore. So let's do something. I promised there's going to be a workshop. This is a workshop, a real workshop you can try with your machines. So here's an agenda. I'm going to boot up like this world's most expensive clock, then write some programmable privacy, and then run it. Maybe it's not, yeah, maybe I should do it in a, yeah, put more information here. So yeah, we're going to set up this development environment. We call it the sandbox because it comes with PXE and everything inside. We're also going to generate some useful TypeScript bindings. Okay, I'm kidding. We're going to deploy with a CLI. But then we're going to write the TS bindings because they are useful. But that's fine. You can leave now. No questions asked, right? Then we're going to write our deployer, which it's also TypeScript, but that's fine. There's a script that does most of the things for you. Then writing a contract, which is going to be very useless. It's the voting contract that everyone can see what the tally is, right? It's completely useless. But still interesting because there's still some private execution because no one can see who you voted for. I think that's okay for a workshop. And then some bonus points for testing, just seeing that it works. I mean, maybe it won't. Maybe I'll make some mistakes. Yeah, anyway. Then I'm going to go on the good stuff, which will be private native account abstraction, which is kind of amazing. Like it is really, really good stuff. But yeah, maybe for another day. I just wanted to say that we have native private execution, native private account abstraction, which is really amazing for a private network. And then enough memes we can hack. This is the QR code for the Noir docs, for the Aztec docs, sorry. There's a link tree right here with the docs as well. Yeah, so that's the Aztec Discord. You can join. I hope the link is still active. And there's the link to the documentation. We'll probably have that as well. And then, yeah, my link tree has my socials and also some workshop resources. There's a kind of a cheat sheet that you can use for stuff that I'm gonna just copy paste, so you can run it on your machines as well, if I didn't forget anything. And I think we're good, like to start. Just gonna wait to stop having phones in the air. Okay, cool. So I hope you can hear me now, still. Cool. So let's hack. Here's so LinkedIn here, you can have a code space if you, for whatever reason, like you're using Windows or something and you don't have a Linux or a Mac machine, you can use this code space. It should work. It comes with the sandbox, so the first part actually already done for you. There's code snippets you can go, and this is just going to open this page, which has most of the stuff that you will need. Yeah, actually, I should have these notes here as well. So there's also like some sheets here at the end. Probably going to use those if I miss something. So the first thing we're going to do, just open a new project. I can start a sandbox. So to install the sandbox, you can go and just run this. That's the first snippet. You go here, you install it, and this will install some useful CLI tools. Just say yes. It will install the wallet, the Nargo, which is the compiler, and Aztec, which is the chain, basically. Just taking track of time. And once that's done, it's just Docker images, as you probably recognize that. I think the font should be, can you read it? Or should I make it bigger? Bigger, yeah, cool. Is it good now? Cool, thank you. So yeah, now you can start the sandbox. You can go Aztec, start. Most of the commands are actually here already for autocomplete. So you can go Aztec start / sandbox, and this will start the sandbox. Sandbox is just Anvil. Okay, no big deal. A layer 1, pretending to be a layer 1. And then there's the layer 2, the Aztec node that is starting. We'll kind of register some accounts. I mentioned native account abstraction, mostly because, so you know that any contract is actually, any account is actually a contract. So that could be useful in a bit. So then we can start with writing an app. So I can go npx Aztec app init. Actually, this didn't work for me yesterday, so I may have to write the whole thing. Anyway, this Aztec app init will, hopefully, it will probably ask you to install Aztec app. This is just, yeah, it didn't work. I don't know why. There's something here with Git. Sorry? Yeah, I can wait. Yeah. So yeah, there's something here that is not correct. So I'll probably have to write most of the stuff. Actually, since we are waiting, I can actually go to the Aztec GitHub and just go and copy that, so we can start quickly. Some boxes, and then there's okay, not boxes. It's init. Yeah, here. And yeah, this is what it should be cloning, but for whatever reason, it's not. Actually, I'm going to put this in the resources here as well, so you can follow along. If you're looking into... Sorry? The QR, yes. Here, you can look at that. Is it good, the sandbox? Or still downloading? It's slow. Yeah. We can wait a bit more, that's fine. Yeah, I'm just going to copy this, so just take care of what was not cloning. And yeah, you see there's some scribble errors, and this is because I haven't added the dependency. I actually want to talk a bit about dependency. So this is, there's some questions around what is the relationship between Noir and Aztec. And this is a good question. Like, this is actually Noir. If you've written any Noir, you know how it looks like. Why did it copy twice? I don't know. This is Noir. But you see some things like these macros, and what are these? And this is stuff that is going to be injected by the Aztec dependency. So Aztec and Noir is just a dependency that you can import, just like any other library. So you do that in argo.toml, and here is the path, which is wrong. I think that's why it wasn't cloning correctly. So, but I have here the dependency. So this is just importing this particular dependency from the code snippets. So yeah, it's just a library, right? No big deal. And so once you save that, hopefully this will stop screaming at you. Yeah, okay, more or less. Anyway, as you can see, there's an LSP, so it'll actually help you autocomplete stuff, which is really cool. It's still kind of in the works, but I mean, it's useful anyway. So, yeah. Turn down lights. Can we turn on the lights? Just these lights to make it easier to read. Thank you. Perfect. Cool. So, yeah, I hope the sandbox is downloaded. If not, you can use the code space. It's gonna probably be faster. And actually, you can even use the sandbox. It will port forward to your machine. So yeah, going back to the code snippets, I'm gonna import these dependencies as well. These are just things that we'll need that we want to import from the Aztec dependency. Again, this is Noir, so we want to be sure that you're not importing the whole thing, you just import what you're actually going to be needing. And this is what we're going to need. We're going to get the public keys. This is to get the nullifier, and also the initializer function, internal, private, public, those are like macros that we're going to be needing. Storage, and then the types of the stuff we're going to be storing, which is going to be just the Aztec address, a map, just like a map on Ethereum, and then public mutable, which is, as the name says, it's something that is actually public and everyone can change, or it can be changed in public. So we are going to actually know and define our storage. So storage, you go and say storage, right? No big deal, and just define storage. So there's this context thing that we need to pass. It wasn't here now, it wasn't here before, and now it is. That's something we need to, I guess, figure out how to get rid of this context. Kind of annoying. So this is where our structure comes into play. So the way that we're going to be doing this is our election or voting thing will have an admin. Admin will see everyone's votes. It's really cool. There's probably only going to be one candidate because that's how democracy works. I'm just kidding. And then there's going to be a tally. Everyone can see that. So actually, all the storage is going to be public, which is fine. It's just as easy as make it private. Actually, it's even sometimes harder to do stuff in public than it is in private. So I'm going to define an admin. I'm going to say admin is going to be public mutable Aztec address. So this is going to be us, right? The deployer. And then the tally, this is a map. So yeah, map it just like in Ethereum. I'm going to use what we call a fill, which is a native type in Noir. Just kind of represents, you can think of it as just representing a number. I would probably going to be killed by saying this, but you can treat it as a bit of a kind of a big integer. Yeah, I hope there's no Aztec team members to kill me now. Anyway, and this map will be just mapping between a number that will be representing a candidate and then the number of votes. So field, and this is going to be public mutable because all the votes are public mutable field. This is where I think I need to pass the context somewhere, everywhere. I think here, context, and I think as well here, context. Cool. And so that's how it goes. The way that we're gonna, okay, let's just actually start with initializer. So let's make it, I think, public. Yeah, it's fine. I think initializer. You can actually call it anything. You don't have to call it constructor. I'm just gonna call it constructor because that's how usually people call constructors. But and I'm gonna pass the Aztec address as the initializer, and this will just set me as the admin. So I'm gonna say storage admin, and then writes admin. Okay, I don't need to return anything, so this should actually compile if I didn't do anything wrong. Let's just try it. Let's just try compiling Aztec Nargo. So Aztec Nargo is if you know Noir, it's just a compiler for Noir. So Aztec Nargo, I hear it's actually now it's the same thing. It wasn't the same thing some time ago, but it is now. But for some reason, it's still called Aztec Nargo. So yeah, just a ton of warnings. Warnings are not there, so just ignore it. I'm just kidding. But yeah, we're gonna eventually have to fix the warnings as well. But yeah, it compiled. Like you can see here, it's like here's the init main thing that seems to be working. So yeah, I'm happy for now. So yeah, it's kind of useless that it just deploys and that's it. So let's do something else. Just see my notes. If I didn't forget anything, no, I didn't. Cool. So we're gonna write the logic. The logic is not very complex. We're just gonna write a private function. So private function executes client side, and the only thing that goes out is just a proof. And that's what's going to be screaming out loud. You're going to be screaming out loud. Actually, you're going to be calling a public function and say, "Oh, add another vote to this candidate." And you're like, "Oh, but the candidate is going to be public." No, it's not. Like, I mean, the candidate is, but who voted is not. So your privacy is still preserved, even though we're just saying to the node, "Yeah, please add another vote to this candidate." So that's part going to be working in public, which is really cool. So to define a private function, you just do the same thing. You just define private, and then just write. Let's write cast vote, and this should be. I'm gonna have a candidate. It's gonna be also filled because it's just like 1, 2, 3, 4, 5, whatever. So we're good. Now we want to. Basically, the way we're going to be doing this is there's a nullifier we're going to create. For this specific app, there's going to be a nullifier. And this nullifier will actually be, so you can't nullify twice, right? For this app, you only can nullify once with your key. Surely you could rotate keys, and that's something that was actually in our roadmap, but I think we're going to drop that. But yeah, it's kind of useless, right? You'd have to do a different logic. So let's call it npk mhash. This is just a nullifier key, and just call it get public keys. That's what we defined before for account. So I'm going to use context message sender here. This is just basically me, right? And then just get the nullifier key hash. You see the autocomplete here doing its job. Thank you, because I'll definitely forget it. So now I have that. I need to create the nullifier for this specific app. You don't want to use the nullifier for everything. Otherwise, people could actually track and see where are you adding your nullifiers, and it could be leaking privacy. So you want to have one specific for the app. So let's say like npk app, yeah, something like that. And this could be how did I do this last time? It was like I think npk hash npm node npk hash, and then did I note it anywhere? I don't want to mess it up. Okay, it says, I think it's here. No, it's not this one. Let me check my notes. Actually, I have the sheets here in the cheat sheet, so I don't forget around here. Yeah, okay, yeah, it's the context, yeah. I know it was something that was already there. So context, yeah, you get, of course, it's context because it's like the private context. You're just saying, yeah, in private, please get the nullifier for this specific app. So you get, where is it? Request and NSK app and just send the master nullifier key. And this should, I think that's fine. And this should be good to nullify. So to nullify, basically, I'm just going to do something that can't be, hopefully, replicated or just attacked in any way. So I'm going to define like a secret, let secret, and do that secret. It's going to be a hash. This is actually Noir, so you can use whatever hash is in the standard library. So I'm going to do that, for example. I think the easiest one is Pedersen, so I'm just going to hash, and then Pedersen and Pedersen hash, yeah. And then it's going to be context, needs a context, this could be message sender. To field, right? Yeah, it needs to be a field. And then another field could be the NPKM hash, I think. Yeah, this is a field. Cool. Looks good. So now I have a secret. Oh, wait, not secret, nullifier. Yeah, this one is a secret. So now I can push this nullifier to my private execution environment. So private execution environment is actually a prover that is running on your machine. Because again, if your private inputs leave your machine, they're not private anymore. So I'm going to say context, private context. Context is a really cool word, because if I call context in a public function, like initializer, it will actually look different. So it's a cool one. So I'm going to say context, and then I think it's push nullifier, read request. I didn't have those in my note. Maybe it was a new version. Let me see. Yeah, I hope this works still. I'm pushing this nullifier, and then it's weird. I get that. And then we're good. Like, we have a nullifier. We can basically say, I can't vote twice. Because if you try to vote twice, it will say, the secret is already this app. So you can't, unless you have a different counter, you can rotate your keys, then you can't vote twice. And if you can't vote twice, that means that you already voted. So if this function calls the public function, then you're good. It will means that your vote is actually you're not going to be able to do it twice. So I can define here now a public function. I'm going to call public function. Just want to be sure I do the same naming because of the interface. Oh yeah, I called it add to tally. And this will take the candidate, which will come from the other function, and say storage. This is the easiest function ever. Just going to get the tally at the candidates and just read it. Okay, going to add that to, like, call it previous or something. Previous. And then this will basically, it's public, so I can read it. Tally is completely public. I say that candidate and this mapping, just get the number of things, and then just write that plus one, right? Storage, wait, what is happening here? Storage, tally at candidate, right, previous plus one. Right? This should be okay. We want to call this function, so I'm gonna call that in the previous function. Say the name of the contract. It's composable, so I could actually have two contracts. That's fine, as long as I had an interface, just like Ethereum. So I can go main. In this case, I don't need it. It's the same contract. So I can say main at, this is going to be, I think, context, and then this address, I think. And then I think it's the name of the add to tally. candidate, it's that candidate, and then I need to enqueue this because I'm going to ask the, I could have different public functions that will just go. So let's say enqueue, and then I'm going to pass public mutable context. Not public, yeah, it's private actually. Cool, I think this should compile if I didn't mess up anything. Okay, woo, happy. Now, there's just one thing that we need, which is to read it, right? And to read it, it's actually not hard because your private execution environment is synced with the network. It should be synced with the network, so you just read from that. It's just like a view function on Ethereum, except you're not calling anything to get your function. You're actually getting it yourself because you're synced with the network. Really cool, isn't it? Like an unconstrained function, it's actually, a view function is actually just calling your own machine. So I go unconstrained. This means that this is not even a circuit. It's just computation. So like plain computation. So unconstrained function, and I can call, how did I call it last time? Just, I don't have that. Just like get tally, maybe. This should be get tally for one candidate. This could be filled. I want to return that. I want to say public field. So in Noir, you always have to make returns public because they're actually inputs. So, and just read and say storage, tally at candidates, read, returning that. So no need to add the return, also no need to add the semicolon at the end. So this should be compiling. Cool. So we have our contract. We can deploy this. Let's do that. Let me just check the time. Okay, we're good. So to deploy, we can use Aztec Wallet. Aztec Wallet is CLI tool. We are actually working with people to actually make this an actual wallet. But we just developed the CLI tool. There's one person that has building that. But yeah, you can use the CLI tool, and basically it's the same thing. You just need to add a graphical interface, and there's obviously the question of where is your PXE running? That's another discussion. In this case, the private execution environment is running inside your sandbox, and this is important because later on we're going to actually be instantiating a PXE client, and you're going to say, how is this private? It is because the sandbox already has a private execution environment. But in a testnet, that's another thing because you're not running your own network, so you want to keep the PXE private. And the name implies, right? Private execution environment. Cool. So let's just start. Aztec Wallet. Aztec Wallet is really, really cool. The way that the team has been building this. So just open this a bit more, because you can actually do pretty much everything. And most of all, you can define an alias. Aliases are cool because you can, for example, deploy 2 contracts or 2 accounts and again give them different alias and then just refer to them later on, instead of having to copy weird hexadecimal strings of the addresses and stuff. So I'm gonna Aztec Wallet, create account. I'm actually gonna reuse the same so I don't mess it up. So yeah, I'm defining here A, it's going to be the alias, and say my account. So when it deploys, it will actually, so here's the account, public key, etc. And then it's just like stored in a local database saying there's just my account, also an alias called last. So you don't, if you don't define it, it'll just like assume that it's the last one, which is also really, really cool. So to deploy these, there's another one that says deploy. Again, reusing what I've done yesterday, so I didn't, okay, there's just, here I need to change. So it says Aztec deploy from the account that we just created that has the alias my accounts. You just say from this account, I'm gonna deploy, I'm gonna deploy this one called init main. So it will, you can actually use the name of the package and then the name of the contract like this, init at main. It will figure out its own thing, and then just send the arguments. So that's the initializer. We're saying that the initializer takes the admin, which is us, so I'm going to pass that. And then also can create another alias calling this my contract. So it's saved under this address. So it is deploying to my network through my PXE and it's stored in database. So it's called now it's called my contract. So at this point you're like, okay, maybe I can get a tally right now. I can see it should be 0, right? Hopefully. So we can try. We can say Aztec wallets and then simulate, because see, why do you want to simulate it? Because you're actually not calling another node. You're getting it from your PXE, so it's just simulating a transaction. No need to call anything, because also that would reveal data you don't want to reveal. Like, who are you asking for? And you don't want that. You just want to get your own stuff. So we just pass the contract as address as your contract. The contract was just deployed from. I'm making this call from my account. So, and then just get the tally. Is it called get tally? Yeah, get tally. Oh, okay. Just saying like for candidate 1, for example. So that's going to be arguments 1, and hopefully this will get me 0. Okay, cool. 0. That's a big int. We like big ints, so that's a big int. Now I want to vote. Let me see. Aztec wallet send, because here I'm sending a transaction. I'm executing a private transaction that will actually make a call on the public side later on. So same here. I'm just saying contract address is the same contract address from my account, and I'm casting a vote for the candidate 1. Just doing that. Cannot find the leaf for nullifier. Oh, I think this is probably because of that thing that is with requests push nullifier. Let me see if this works. Should work. Need to compile. Yeah, I don't know. So I have an account, so I can deploy from. Yeah, I can deploy it now. I think yes. Okay, so now I can send it. What's happening? I compiled. Just gonna copy the cheats from for this. I know these work. I tried that yesterday. So. Oh, yeah, I forgot the internal, which is cool. Otherwise, you could actually call this public function and add random votes. Not probably what we want. So try to compile that again and deploy. Please work. Okay, it works. Yeah, I don't know. I think it was the internal thing that was missing. Anyway, now it says like, yeah, I did make a transaction. Actually, a transaction has an alias, so if you want to get like the transaction hash or stuff, that's fine. You can do that. So now if I call the get tally again, I can. Where is this? Simulate. If I get the tally, it should add 1. And just to prove that it works, I can actually try to vote again. And hopefully it will fail. Yeah, it says that it's unable to be added to the state and it's eval. I think it doesn't even like do anything because it can't make false proof. It just says, yeah, can't go further than this. So far so good. I'm actually happy for this. And let me see, just the time. Cool. We're gonna have some time for questions, which is really, really cool. So doing the wallets is cool. You probably want to do this in a browser. So first thing you want to do is install Bun, right? Okay, this is, if you don't like JavaScript, if you don't like TypeScript, if you're like me, just use Bun, okay? It's really cool. You just use a TypeScript, you write TypeScript, and it works, okay? So if you want to do that, just go, and it's the last time you're going to run an npm command, so go npm ig and then Bun, right? And this will install Bun, okay? Please, please, do that. It will, yeah, it will save. Yeah, it's the first thing you should do in any machine. So now that we have burn, we can go like actually start a new project and say just create index.ts. Yeah, I think I can go with the browser already. Don't need to. Yeah, let's immediately start with the browser. I could show like a little test script, but I really want to show you the browser. Maybe it will fail. There's many things that can fail with the browser, but still could be cool to show you. How can you actually use an app, like an actual web browser app, and use it to vote privately? Isn't that amazing? Like, it's really cool. So for that, I'm going to use npx, or yeah, let's call it Barnex, which is the same thing. I just don't like npx. Yeah, I'm kidding. npx, that works as well. npx and then create vit. Here's the command. It just starts. It's a template, so I mean I can actually do this, create vit, and just like this, and it'll ask me what I want. I say, yeah, just ignore and just add your files to here. Just gonna choose React and then choose TypeScript React. And here I have a like very simple app that just hopefully works. And I can actually try to run it, run dev. And okay, what is run dev is not here. Oh, okay, I forgot to install dependencies. So here I have, I mean, it should be working, like just the normal burn app. Just want to be sure. Okay, cool. So let's start writing some stuff. I want to install two kinds of dependencies. The first one is the Aztec dependency. So Aztec JS and Aztec accounts. These are, Aztec JS is the interface to Aztec. It allows you to call contracts to interface with your PXE. So that's what it does. And Aztec accounts provides you an easy way to create accounts. We're actually going to use a testing account because, I mean, it's just a workshop. No need to. We're actually using test accounts is cool because it creates a new one every time. So you can actually have more than one vote if you just restart the app. So yeah, install that. One thing is like Aztec.js is not yet really optimized for the browser, so we're gonna be using some polyfills. So if you know a bit of JavaScript, you know that JavaScript can be run on the browser and the node at the same time, which is cool, but also a bit annoying because I mean JavaScript was made to make things flash in the screen, and we actually suddenly make it in the browser, in the node. So yeah, we're just installing some polyfills to say, I've written this for Node, but I also want it to work in the browser. So to do that, I'm going to install some Vite plugins. Oh, here they are. Top level await and the polyfills. Top level await, I don't even know why is it there like by default. Most browsers already allow you to use top level await, which would mean like just writing await here. But yeah, for some reason, I need to use a plugin for that. And then node polyfills, it's just what I just mentioned, some stuff that is in the node but not in the browser, so I want to have that. So let me call top level await from Vite top level await, and then import, I think this is a named import, which is node polyfills from with node polyfills, and just using that as plugins, top level await, and then node polyfills. Okay, so I'm good. I think it won't break. So we're good to actually write some Noir code. Oh, one thing I need to do. I mean, I don't need to, but I want to do is to create an interface. So really cool about things in Aztec is like you can actually create a TypeScript interface that makes it very easy to interact with the contract. So if you go Aztec codegen, I'm going to point this codegen to my target, which is here. So this stuff has actually all, it's a bit of an API, as you can see. It also has all the bytecode and everything, so there's a point where it just can't yeah, it's not human readable, but the first part is. And so it can actually use that to generate an interface to say, oh, you can call these and these and these types to these functions. And so that's what it's going to be doing into the artifacts folder. So look at this, really, really cool. Like you can call this function. This is a class. You can call this class and get like pointed at the different addresses that deploy it. And most of all, it allows you to call these functions. So you could just import this file and just use it as you want it. So CodeGen is really, really powerful. So I'm going to actually kill this index TS. Also I deploy these. I'm going to deploy again just because I want a fresh contract. Deploy. So we only see one vote, hopefully. So I have here the deployment. Just call it, add a new file, say deploy text, just so I don't lose it in the history, the terminal history. So now I'm going here to my I think app.tsx. It should be okay, and I'm gonna instantiate a new wallet and say, oh, here's a new wallet. Again, it's kind of stupid because if I redeploy, if I just refresh the page, I'll get a new wallet because it's a testing wallet. So if we restart, we're going to be seeing like 2 votes, 3 votes. That's fine. And so here's like import, and I want to import the stuff from Aztec. So I guess create PXE client. From Aztec.js, I want to create an account. So create account from Aztec accounts. I'm going to call the testing ones. So if you see here, it's really cool. Like it just creates a random account. And then I want my interface. Import main. I think it's also named main contracts. From, where is it? Artifacts main, right? Is it called main contract? Yeah, it is. Cool, so first thing, I want to instantiate my PXE. So I'm going to say PXE, create PXE client. I'm going to pass the URL. So as I mentioned, PXE is running on my machine because it's part of the sandbox tooling. So HTTP, localhost, 8080. Now you see what's the problem with the PXE. Where does it run? If it has your private inputs, where does it run? It needs to run in your machine, right? If you're using Aztec, you want your private inputs to remain private, and they need to run on a phone, they need to run on a desktop, whatever you're using your wallet. Your inputs can't leave this place. So in my case, it's not leaving my place. It's just calling my own server. So that's why it's 8080, whereas the sandbox is running. So I can go PXE, create PXE client, etc. Now I want to create an account. So just going to say, let's call it wallet actually, and say create account. Oh, create account, and passing the PXE. So it registers in the PXE and says, here's my account. So now I should have wallets. I'm good to actually go and I already have deployed the contract. So let's just go on the standard. Standard React development here. As with every React development, you just remove everything, right? First thing, that's because you don't care. I'm going to write 3 functions. Those are like starting, just to getting my contract address and everything, an interface, and I'm going to also be able to vote, and then I'm going to be able to see the votes, and that's enough. So I'm going to write an init function. It's called async. This is, okay, for example, contract. Const contract. I'm going to say await main contract at the address that we have stored here. I mean, usually we'll actually deploy with JS, which is also like just main contract.deploy. Not a big deal. I'm going to pass that here also my wallet. It's probably yeah, it's going to complain because it says, oh, it needs to be an Aztec address. That's fine. Just cast that to an Aztec address and say from string. And it says, cool. I just get a string. I just pass it, just convert it to an Aztec thing. I think I need to wait here. Cool. So I have contract here. I'm going to store that in my state. Set contracts, use state. It will complain about the type, so I'm going to pass the type main contract, just make it be 0. Then I can set it here, set contract. So if you know React, this is the kind of standard thing you would do. Also, this is the first thing I want to do, so I'm going to use effect, create an effect, so it starts. That's the first thing it does, but I can't use asynchronous functions in use effect. It needs to be synchronous, so I'm going to call init here. And then when I render, that's when I'm going to say if there is tally, I'm going to go ahead. So to get the tally, I'm going to say get tally. Same thing, async, pretty much the same kind of development flow. But now I should have the contract. Actually, I may not have the contract, so I'm going to go contract. Hope it doesn't break. Contract methods, right? I want to call these methods, and as you can see, I have all the methods except the one that it's public because it's internal. So I get cast vote. I'm going to pass 1. That's my candidate. I'm going to send. This is not simulate. It's a simulate. Yeah, simulate. Then that's it. I'm simulate. Just as long as I await that, I should be able to get a tally. And wait. And yeah, you know what? I'm gonna also add that to the state and say tally, set tally. At this point, I think my fingers already know how to write this. You know, just it's a big int and just make it 0n. Does it work? Yeah. Yeah. This thing is new. The n thing. So I can set it here. So I set tally. And this is cool. So it works. It should work, right? Now, finally, I want to vote. So vote. Sync. You probably know what I'm about to do. It's just the very same thing. I'll just say await, contracts, methods, cast vote. Oh, wait, it's not cast vote here. It's get tally. Cast vote. 1. I'm going to send. I'm going to wait for it. Wait for it? Yeah. I'm going to update the tally, right? I'm going to wait, get tally, because I want just having it shown on screen easily. So now I'm good to write our good old HTML. So just call it voting contract. And just make it a paragraph. I'm going to say tally. Tally cannot be there, right? So I'm going to maybe tally here. Then say, so tally is, that's why it says toString, because tally is a big int, so I need to go to string and maybe cast it to base 10. Yeah, I think this will work. Otherwise, it will complain it can't really render big ints. And I'm going to add a button as well. So like on click, I'm going to go click and vote. And just, again, so vote for the candidate. Other candidates are not available. It's democracy. Cool, so I think this is it, like, right? I didn't forget anything. So I can actually go and try run dev. I'll be surprised if this works. Oh, yeah. Yeah, it's complaining. It says that it can't resolve FS promises. I think I may have been too optimistic about the node polyfills. I'm going to exclude that. So exclude just the FS, see if it works this way. Yeah, okay. I'm very surprised. So let's try it. it could take a while. I think the JS, it's kind of big, so that is probably why. Or, oh, cool. Oh, did I get 0? Nice. So what happens if I vote? I'm going to open the console because it's probably going to error. Voting for the candidate. There's no spinner or anything like that. Cool, I have won. Woo! So what happens if I try again? So hopefully also fail. Yeah, it failed. Cool. So let's just restart this and see. It should actually go and see twice if I start a new one, because like the app is going to be, it's going to create a new account. So this should actually have 1 at first, like immediately, because it thinks that someone has voted already. Okay, no, it's 0. Oh, because it's 0 at the beginning. I don't get the tally at the beginning, so that's why. But voting, it should be 2, maybe. Yeah, cool. Yeah, so it works. But if I try again, it will just say, oh, that key has already voted. That you can do it twice. How cool is this? Like, it's really cool. This doesn't leave your machine. Like, actually, I think the PXC is not proving, because there's a flag that I need to pass. These guys should know if I need to pass a flag. So, but the proof is not. In this case, the proof is not even too big, so it wouldn't even take a long time. Let me see how much time do we have, so we can maybe look at some other code. Let's see. Yeah, do you have a lot of questions? Or okay, I would say yes. So yeah, I'll leave like 10 minutes at the end. Should be enough. Yeah. So let's look at some stuff that has been done here. First of all, I want to look at the contracts. So one thing that you may want to know is what about Ethereum? What's the thing about Ethereum? You never touched Ethereum apart from using Anvil. But if you look at the actual sandbox here, you can actually see that there was a rollup being made. You see, there is a rollup being sent into Anvil. And if I do get the Anvil logs, I should see the logs there. The thing is, like, you can actually pass messages from L2 to L1 quite easily. So if you see the documentation, docs.aztec.network, you can see here in the references, you can see how to do that. So I think there's even an example with that. So here we will be able to make a token bridge. So there's an actual example on what we call portal contracts. These allow you to make message passing very easily. It's done via the sequencer. So you can basically make it quite easy to, by deploying a contract on L1 and another contract on L2, you can actually pass messages. It will take some time because, I mean, there's message passing takes time for the block time, but still, it's really interesting because you can actually move funds into L2, make whatever you want to do, and then maybe pass into a different L1 if you want to, because it's not even like, it's unrelated with the kind of network you want to connect to. But obviously, there's going to be a rollup. So at the end, if you see the architecture and the resources here, you're going to see that there is going to be a rollup that will be done with all the transactions. So the architecture kind of implies that there's a sequencer. The sequencer will kind of order all the transactions as they want. Like, I think there's going to be a rollback solution with making it a base rollup or something. But yeah, there's going to be this transaction ordering, and then the sequencer will say, "Oh, I need to prove this now. Who's available?" That's pretty much that. The sequencer can actually prove it something if they want. It's going to be a big proof with all the transactions will be proven and be rolled up into this rollup proof, and will be again be verified by the sequencer, which will post the proof on L1 and verify the whole transaction. Verify the whole block in one proof, which is really cool. Or the sequencer can say, yeah, I have a marketplace, for example, and I can delegate my proving to a marketplace, and whoever bids the most, then cool, I'm going to go with that, or the least in this case. I'm going to pay the least to prove my block. So it's really cool the way that the thing works. So it's actually a ZK thing. ZK in the sense of there was privacy, and also ZK in the sense of all the transactions are going to be rolled up. So this is probably my favorite thing on portals. You also have another really cool thing, which is, try to find it, not portals. Where is it? Maybe here, concepts, storage, partial nodes. So partial nodes is really cool because you can actually, did I say that you can do the real life, represent real life in Aztec? It's really cool because if I make a trade with you, like a swap, it's actually going to be a two-transaction thing. I give you something and then I wait for money, for example, if I'm selling you something. And so we actually want to do better than that in Aztec, where there's no two transactions. Because if I'm selling you something, we can also trust a third party and just say, oh, please hold that for me, and then when you get the money, then give it back to me. So there's kind of an escrow. But they're like, we can do better. And so we built this idea of kind of atomic swaps. They just run at once. You can have someone actually pay the fee for you, for example, for this situation. And so you're making some computation in private, and then whoever is paying for the fee can actually update that point in public and say, oh, even though you said some random value for the gas fee, for example, I'm actually going to update that and pay the gas fee for you and then send you back the remaining, or just create another node for you. So there's some cryptography involved, but this is really cool for, again, private swaps, or you could do it at once. So partial nodes is also quite interesting. And cool. So as far as other contracts go, you can actually start really easily, and I could make this workshop very small if I just deployed one of the boxes, just call Aztec init, and then create either a React app or just a vanilla app. This was very, very cool to write. This is just, I like JS, like the real JS, like real stuff, no frameworks, no stuff like that. So I built this that just use actual event listeners and everything, just to prove that there's no black magic here. This is just JS, the purest thing you can find. It's actually TypeScript. And anyway, this is an example of something that works if you just want to have a very, very, very simple thing that comes with most of what you want on the browser, but you don't like React, for example. You can also see on the repository, you can see Noir projects and then get some example contracts. And here you have some really, really cool examples. Some of them we actually need them. Some of them were written by us, like, for example, in an internal hackathon. So, for example, this crowdfunding contract was written by us in a hackathon. The reason we did that is because if you probably remember the Constitution DAO, where people were actually donating to a contract so that contract could buy a unit of the Constitution. One Constitution of the US. And so there was someone that would actually go to the place and bid, or click to bid for that document. But because the donation contract was public, was on Ethereum, everyone could know how much money was on the DAO. So basically, there was just someone that just knew, okay, these guys will only bid up to a point, so they just bid $1 more, and they got the Constitution. And that's not cool. That's just not cool. Like, that kind of tells you how useless it is, like, if everything is public. So what these people did was basically, this contract allows the bidder to be able to know if he can bid, but not know how much is in there. So it's like, oh, I'm going to try to bid. Oh, it works. I'm going to try to bid. Okay, ran out of money. That's it. That is really cool of an example. So I thought it could be interesting. Let me just see if we can go to questions. Yeah, I think we can have questions, and maybe expand a bit on that. Michael, do you have a question you were about to ask? Yeah. The micro, yeah. Oh, you mean to add to the private? Oh, yeah, I mean, you can, yeah, usually would have like some kind of Merkle tree, for example, that would say only these people can vote. Because right now, as the contract is, like this is a very stupid contract where like anyone with an account can vote, so you can just create a different account and vote, that's fine. Yeah, definitely, you could use like, yeah, I mean, you're from the ZK passport team, so you could actually use your passport to like you can use your passport to create an account.
That sounds amazing. Please say more about this.
It is amazing. Yeah, you definitely could create an account. Like, so Noir is a really nice language, so you can actually verify random signatures or different signatures inside the contract without revealing what the signatures are. So what these guys did was just like, oh, I'm gonna. Electronic passports have an RSA signature, so what I can do is just get that signature from the passport and then be sure that you have one account.
One passport, one vote.
Yeah,
right?
one passport, one vote.
Completely private, anonymous.
Exactly.
Yeah.
Like everyone, you can vote if you can prove some things about that passport, but like for example, your nationality would be kind of important for voting. Or whether you have more than 18 years old, if you could vote, at least in Europe, it's 18-year-olds, maybe, I don't know.
I think it varies, but yeah. Roughly.
So yeah, that's really cool. You could use your Face ID for a wallet. You can actually, since every account is a contract, you can actually use different recover mechanisms where you lost your passport, oh, now I lost my wallet. No, you didn't, because you can actually recover it by ZK email, or you could basically have an email be sent to you and just prove that you received that. Things like that are really, really powerful. And again, you can see their contract, ZK passport. I think, I mean, it's not here, obviously, but there's somewhere in GitHub. You can talk to him later.
GitHub.org/ZK passport if anyone's interested to see the Noir contracts.
Yeah. But there's also an example of a different account contract that uses, in this case, for example, ECDSA, SecP256 R1 signatures. And this is, for those who don't know, this is, actually, it doesn't tell what the curve is, but this is like, for example, Face ID signatures. So you can have a wallet by using your face, using like Apple Secure Enclave uses SecP256 R1 signatures. Also some passports and some citizen cards. So you could use that to create an account, for example.
And the Portuguese national ID, I believe, also supports this curve.
Yeah, definitely. I managed to lose my identity card, which conveniently let me get a new card, which has a SecP256 R1 signature, totally unintentional. So I could actually play with it and to see the new signature using LT curves. So some citizen cards, again, will, I guess, over the next few years, will start having, I would say, better or easier signatures to verify. But that's fine because you can do RSA signature verification very fast as well, so that's fine.
So one cool feature of this might be you could add the national ID card as like a account recovery option.
Yes, you could do something like that using the same mechanism, which is again very powerful. Cool. Any other questions? Yeah. Sorry, any I can't hear.
Can I compile your contract and deploy it to L1?
No. I mean, no, because like every function in this contract is a zero knowledge circuit. So this one is a zero knowledge circuit. This one is also a zero-knowledge circuit. This one isn't a zero-knowledge circuit because it's unconstrained. So these are actually, this is going to be run on the client side. That's the only difference between private and public. Not the only, but I mean, it's the biggest difference is where do they run. So if you deploy this on L1, you can actually, I mean, you wouldn't be able to define private things in L1. I mean, maybe you could, for example, do something, some kind of compiler from Solidity into Noir, and maybe, for example, add the decorator into Solidity. I think there's an EY team that has been doing that. I think Starlight has been doing that, where you can actually add the decorator to a Solidity contract, and out comes a circuit. So this could be something like that, but to do the other way around, to have a zero-knowledge circuit and make it into Solidity contract, it's hard. What you could do is, for example, write a Noir circuit and then generate a Solidity verifier for the Noir circuit and then verify that proof in Solidity. That's possible, but not with this. I don't know what would happen if I go here and try an Argo contract. It'll fail in many ways because I don't think it knows anything about what you're trying to prove. The macros will probably ask for something you don't have. But definitely, if you use the Noir circuit, just any Noir circuit, you could just generate an Aztec contract. I can show you later on. It's strictly Noir development. But, so basically, you write something. Some of the inputs are private, some are public. But then you send to the smart contract only the proof and the public inputs, if needed. I mean, usually the Solidity contract has the public inputs. And then the thing will verify. You can use that, for example, to create a safe, for example, that doesn't reveal who are the owners of the safe. So I did that, me and Theo, some time ago. That was an example of just using Noir as a really cool authentication mechanism where you have a safe and you don't actually verify the message sender to know if you can or cannot change the safe or make transactions. So it's a really cool one. Cool. Do we have any more questions? Okay, let's see if we have time. Otherwise, we'll just, I guess, stop here. Let me see. Yeah, that's fine. Cool. No other questions? Last call? Cool. Just feel free to visit Aztec docs.aztec.network. We are going to be launching a testnet soon, TM. When I mean soon, it's really soon. It's not like soon, but in 3 months. No, it's going to be. We already tried some things with you can check on our Twitter. We usually post about this, about a testnet, that a prover testnet, where people really went way overhead, over the moon to try to prove blocks. We made a little insignificant competition. We thought it would be kind of friendly, but people went up like racking up with big provers to try to be the fastest. And they're like, okay, people are going crazy with proving Aztec network. So we tried that. We also tried a development network that's also distributed, where you can actually create contracts, even send dummy tokens to people, and that was really cool to see. It went down quite often, and now it's currently down because we just care about keep building and not maintaining some other testnet. But yeah, now we're going to be doing everything. some testnet that will do everything. It will prove. It will. I think public thing will not be proven yet because we're working on that still. Here you have some tutorials that you can try. Private voting, the crowdfunding I was mentioning, a counter contract, and probably one that you like to see, the private and public token contract, which would be it's a nice example. There's also stuff about the dApp that I kind of covered in this workshop. And finally, Uniswap bridge. This is cool if you used Aztec Connect, you're like, oh, can I have Aztec Connect on Aztec? I mean, that's just a contract, right? That's how powerful Aztec is. We can basically have functionality that was before. You can actually write a contract and have the same thing. So this is an example of how you do that with architecture and everything. We know quite a lot about this because we've built it. So that's an example. You should follow our Twitter. You should apply to our alpha build programs, which are basically they are programs you can apply to build some specific thing about the network. I think we had like 3 editions so far about creating wallets, about creating tooling, about creating indexes, and so these are like actual competitions where there was actually some grant money for that. Speaking of grants, there's also grants you can apply for if you're building tooling, if you're building things for Aztec. These are you should look into grants. And finally, if you are more into the infrastructure, we have a ton of things that we are basically wanting the community to do, like writing clients, writing wallets, writing block explorers, writing, I mean, everything that goes around the network. We only are developing the core stuff. So everything else is up for you and up to you to grab. And this is posing a big opportunity for people trying to get into probably the biggest next chain that there will be. So there's, don't tell me I didn't warn you. Just kidding. That's a big one. But if you're into that and exactly how things are being built, you can actually check also the forum.aztec.network. And it's basically just a forum, but it is really cool. It will tell you how, for example, this is a very important discussion, node discovery, because you don't want your PXE to be trying to decrypt all the nodes and trying to see which ones it can decrypt. So this is an example of an ongoing discussion that I want you to give your input and to be part of discussion. Your request for proposal can be part of the Aztec network. Your input is very, very valuable. So everything from learning resources to actual proposals on how are we building the network are here in the forum. And I think that's it for today. Let me know if you have any other questions. Reach me here in this link tree. Send me a message on Signal, preferably. But I mean, it's fine if you contact me on Twitter. I'll just tell you to contact me on Signal. And cool. Hope you liked it.